8K block size, 16K block size, you probably only need one block size. Question 4, moving to a new block size. Now let me talk about multiple block sizes first. There's a lot of rubbish out there about why multiple block sizes are a really good thing. And most of them are historical and they're pretty much wrong. The only reason we invented multiple block sizes back in, I think, Oracle 8.0 was we introduced a feature called transportable table space. And obviously, if you were transporting table spaces between multiple databases that had different block sizes, a single database had to be able to support multiple block sizes. That was the motivation. People just lost their minds when it came in. They said, "Oh, I know why we're implementing it, because we occasionally get these kind of errors when we're trying to build indexes." Now, I can tell you, multiple block sizes was not designed to solve this. Good database design was designed to solve this, because if you got indexes that are longer than 6 kilobytes in length for a key, I got to tell you, that's the wrong key. That's the wrong column. Or people said, "Oh, if I've got massive block sizes, then my indexes will be shallower because indexes are implemented as a B tree. So if I can cram more data into the branch blocks, my indexes will be flatter." That's also pretty much a nonsense. You can put, I think it's several billion rows, depending on the size of the key, literally several billion rows into a B tree index of level 3. To jump to level 4, suddenly you're up to the 64, 100 billion row kind of mark. The reality is, if you got that much data, why do you have index access to that data? It's pretty rare. Most databases in the multi-billion row range, I say most, not all, are generally data warehouses. And it's extremely rare you'd be relying on heavy index access to them anyway. If you are, you maybe got some physical design issues you maybe want to tackle. It's extremely rare. And the other one is, oh, well, maybe I want less space in my data warehouse because every block has a block header and some block overhead. Once again, you're probably looking at reclaiming just a smattering of bytes per block. Even if you've got millions or trillions of blocks, you've already in petabyte range. Well, yes, you might save a few gigabytes here and there, but let's face it, you're still in the petabyte range. A lot of those arguments just don't hold water, even though people have blogged extensively about them in the past. Probably the best authority of this, if you search on the Google sphere for a guy named Roger McNichol, he's a very intelligent guy inside the Oracle organization, deals with a lot of Exadata and storage technologies and knows this stuff backwards. He's got a great blog post which simply says, pretty much you should stick with 8K. It's tried and true. It works absolutely fine, unless there are particular boundary cases that you need to worry about. And some of the examples might be there is you might have every row might be, say, 9K, just that little bit larger than 8K. There are some very small boundary cases that you might want to consider a larger or different block size, but the reality is 8K is pretty much going to run sweet for you. But this is not being critical of the person that posed the question. They were saying, I want to get all my systems back to one block size. They had a 16K table space. They'd like to move all the data to 8K. So let's see how I would go about doing that. I've set up some examples here just to show on my little database here as to how I would do it. As you can see, there's my list of table spaces. I'm using a stock standard 8K block size, except I've created a new table space called Demo 16K, which has a 16K block size. Just for the people that aren't familiar with multiple block sizes, if you're going to have any particular block size in use, you have to have a buffer cache allowance for that. So I've set my 16K block cache size here to 64 meg just to hold some data. This is to help our person that made the question. He's got all these objects in a 16K table space. How do I move them to an 8K table space? You have to do it generally on an object by object basis and look at some mechanisms as to how you would identify those particular objects. Here's an example of, I'm going to go the opposite here. I'm going to look at moving objects from my users table space into this 16K one, but it's really just the same process. I'm changing the block size. So you go look at DBA segments. As you can see, I've got dozens and dozens of them. But what you want to do is tackle them on a object type by object type basis. So let's look at some examples of how you would tackle these things. Here's the most simple example. If I have a table, which is just a stock standard heap table, I've got some rows in it, and I've got a primary key and some indexes on it. Those ones, if you're on 12.2, really easy. As I can see, all the segments there from that table are in the users table space, the table itself and the two indexes I've created. My first cut of this is alter table, moved it to the new table space online, works fine, no interruption to service. That seems really, really cool, except by default, what I'm doing is moving just the table. My indexes stayed valid, but they didn't get moved. That in itself is a good thing. I could move a table without an interruption to service, but the indexes didn't come along with me. If I want to move everything, it's just a slight alteration to the syntax. You add the update indexes clause, nominate the indexes and their new table space, and then you can see the whole lot got moved over. So I'm moving from 8 to 16 here, but the same logic applies to move back. The vast majority of tables in 12.2 is just a one-liner. Grab those tables and off they go. What about more complicated examples? So here I have, for example, a table that has a lob column in it. How do I deal with that? Because when I create a lob column, I could actually create multiple segments, one for the table and then one for the lob index and one for the lob segment itself. All those things might actually sit in table spaces of question. I've tried to do an alter table move here, and as you can see by default, it's similar to the indexes. The table got moved, but my two lob segments are still sitting in the user's table space. But once again, in 12.2, it is just a one-line command. You just need to augment the syntax a little bit. I'm moving the table, and I'm also moving the lob using a store as syntax to move that to the table space as well. And as you can see now, the lob segments have also gone to the new table space. Tables with clobs, etc. can all be moved pretty simply. Here's where things get a bit more interesting. Here I have a table which is partitioned and subpartitioned. All of those things will be in the user's table space. Let's try do an alter table move. You can't do it. It says you can't do an online table move for that table. Let's try move just one of the partitions. I can't move a partition if it contains subpartitions. So let's now dig right down into a subpartition by subpartition at a time basis. And I have a problem. The reason for that is all the partitions of a table must sit in a common block size. That makes a problem because I couldn't move the entire table, but I can't tackle it partition by partition at a time either. This is an example of where I'd probably get into using DBMS redefinition, as we saw in the previous demo. Just to sort of finish this off, as you can see, I can generally move the vast majority of my objects with one-line commands, just on a table-by-table basis. And for those special cases like partition tables, etc., I'd have to look at something a little bit more convoluted using DBMS redefinition. And that's how you'd piecemeal, without outage, move all objects over to a new block size in a new table space.